Alright, so this video is to recall you some steps to find the probabilities based on the z values. Right, just like in class, we went through this example about the Gallup poll. Alright, if you still remember, we say we have the population mean mu is 315. So, population standard deviation sigma is 30, sample size is 42, sample mean x bar is 200. Right, so then based on that, we check the assumptions, and then we say we can calculate the z-score based on our formula. Alright, so then in this case, we say the z-score is negative 3.24. So in the previous semesters or in the previous course, you may learn how to use the z-table or t-table to find the corresponding probabilities. But in our real life, it is not quite possible for us to bring the tables with you every time you need them. Right, so then here I will just show you how to use the jump, right, to find the corresponding probabilities instead of the tables. Alright, so that will be quite easy steps. So then in this case, we go to the jump, right, and then go to help. In help, there is one option called the sample index. Right, click that. So from here, you can see there are two types of contents. Right, the first type is called data. Right, so jump will provide you some practice data so that you can use it for practice. Right, the other kind of contents will be the tools, which is the one we will use today. Right, so tool. Alright, okay, so then you will see many different kinds of tools, right? Easy for us to use. So then in this case, we are trying to find the probability based on the z, or we say the normal distribution. Right, so then we are using the distribution calculator. Right, so this is the tool we want to use. Right, so this is a built-in tool in the jump. Right, so distribution calculator, open. Right, so once you open it, you can see a default screen. All right, so the default distribution here is the normal distribution. Right, if you click here, you can see many different kinds of other distributions. Right, but now since in this course, or for now, we are using the normal distribution. Right, so then let's use normal distribution. So in default, we have the mean 0, standard deviation is 1, which is called the standardized normal distribution, right? So then in this case, we say we have already calculated the z value, which is from the standard normal distribution, right? So then we will just use this standardized normal distribution. Right, and then you can see the two types of calculation this tool can provide. The first one is you can input the values and calculate the corresponding probability, which is the one we are looking for, right? Okay, the other one is reversely. If you have the corresponding probability, you can also calculate the corresponding z values. All right, okay, so then next you can see this graph. All right, so this curve, we call it is the z or normal curve. All right, and then it has the mean, which is the center of 0, standard deviation is 1. All right, so then in the default input z value is 1. Right, but of course we can change that based on our problem. Right, so then based on our example, what we are looking for, we are looking for what is the probability that the mean cholesterol level of the sample will be less than 200 milligram per dl, right? So then in this case, we are looking for what? We are looking for the probability to the left of your z, right? So we have already converted this 200 to a z value, which is negative 3.24. So then in this case, right here, you need to choose what option or what kind of probability you are looking for. The first option is called x less than q. So the q here is the value you input here. So that means we are looking for the area or the probability to the left of your z, which is the one we are looking for here in this example, right? You can also choose the other option. We are looking for the probability to the right of your z, right? You can also look for the probability in the middle of your z, of two z values, for example, from let's say -1 to 1, right? So you can look for the area or the probability between two z values. You can also look for the tail probabilities, right? So these two tail probabilities. All right, so now let's just go through this example, right? Our example, we say we are looking for the probability to the left of your z, right? So then will be the first option, and our z is not -1 anymore. So in our case, it's -3.24. Enter. And then you can see that the probability is 0.0006, right? Okay, so now in this case, we say, why in this graph nothing is shaded? That's because what? That's because our z value is -3.24. Less than -3.24 will be far away from the center, right? So it will be somewhere here. So it doesn't mean it is not shaded. It's just by our vision, it is hard to see that very, very small shaded area. All right. Okay. So for example, if our z is not -3.24, for example, it's -2.34, right? Then you can see that the left area will be shaded because it's quite large. It's not kind of near to 0. All right. Okay, so this is the first method. The other method is we say this is the default setting. We use the standardized normal distribution, right? So that's why we need to calculate the z first. Is there any other way that we don't need to calculate the z first? Of course we can, right? So we can use our sampling distribution. We say what? We say in class we talked about that, right? So we say once we select the sample, we have the sample size and then population standard deviation sigma. So that means what? That means our sample mean will follow a normal distribution, that the center will be the same with the population mean, and the sample standard deviation will be sigma over square root of n. Right? So then we call this is the mean of the sampling distribution. And the whole thing here is called the standard deviation of the sampling distribution. All right, so if you don't want to calculate the z first, then you need to say that, okay, now this distribution is not a standardized normal distribution. It is a sampling normal distribution. So then here the mean will not be 0 anymore. It will be what? Will be the same with the population mean, which is the 215. Right. Standard deviation of the sampling distribution will be sigma over square root of n, which is the bottom of this formula, right? 30 over square root of 42. So if you calculate this part, it will be 4.6291. All right. Okay, so then now the value you want to input is not a z value. It will be a real sample mean. So which is what? Which is 200. So if you enter that, we will have exactly the same probability. But now this distribution you are using now here is the sampling distribution. It is not a standardized normal distribution anymore. All right. So here I just introduced two ways to get exactly the same answer depending on your preference. All right. For me, I think use the standard normal distribution calculate z is easier for me to understand what is going on. All right, so I will prefer this one. But if you really understand the sampling distribution very well, then this one is also very easy to save you time on calculations. All right, so either way is okay. So that's why I use the or. All right, so either one is okay. All right, so exactly the same results. All right,